I'd like to show you now an example of a SQL management console. I have made a remote connection to another machine that has a SQL database management console running on it. This is Microsoft SQL Express, and very many applications are built using this free version of Microsoft SQL. And of course, there are many applications also built using some of the open source versions of SQL as well. But if we take a look here, we can see that we have a connection to a particular server, my server. And when we open up databases, we can see that this management console shows us several different databases. I have 2 production databases here. And then I have system databases just to manage the SQL server itself, and also system databases that manage the databases. I can see that I have security, and I have logins, and then I have connections to servers or triggers to connections to servers, and also any backup devices. And if I have any replication between SQL devices, it's very frequent to have one database replicate constantly to another database, even in another machine, even in another town. SQL databases, SQL servers can ship their logs across, say, a WAN link to another SQL server, or just one on the same network. And then also any additional management here, like the logs and the activity monitor. So when I look around here, I can drill down a little bit, and I can drill into one of the databases, and I can see the tables, and I can actually look at the tables here. And the table then has the columns. And so I can see these are the different names of the columns, so these are the attributes. And then if it has any keys, if it has any primary or foreign keys, this one doesn't have any. Are there any constraints, any restrictions? Are there any triggers? So like if I update one table, does it cause other tables to update? Are there any indexes on this? A very big part of database management is to re-index the tables, because the tables constantly add data, they change data, they move data around, they delete data. And so when you have all these records being added or deleted or modified, a very quick way to find something is to index the table. It's just like an index in the back of a book. And, but you have to update those indexes constantly because the data is constantly changing. And then maybe for security, I can have some views. And a view is something like, I have some people who shouldn't see everything on a table. So I hide certain columns, like maybe some HR people should be able to see like everything about the employees, but certain people should not be able to see social security numbers or salary amounts. So I create a view that limits how much of the table they can see. So database management is a whole big management art in itself. Architecting the whole database design, keeping an eye on it, creating the relationships between the tables, making sure that the performance is good, always monitoring the performance. And you're going to have whole teams of people actually responsible for just managing the databases themselves. So this is just a quick view of kind of a typical example of a console. If I scroll down, I can see if there was any activity. At the moment, no activity. If there were any logs that were created as well. In this case, I don't have any logs. I actually threw an exception. But here is but one example of a typical console. When we are querying a database, we'll use something called the structured query language, the SQL language. And developers who write applications, they will build these queries right into the application because this is the language that the database speaks. There are many flavors of the SQL language. There's Microsoft Transact SQL, there's Sybase SQL, there's Oracle SQL. If you know one, it's not too hard to learn the others because they're very similar. But the structured query language, we can use it not only to get information out of tables or out of multiple tables, we can use it to update data, to insert data, to delete data, to create things like tables and views and indexes, to create whole databases. We can create structures or schemas, and we can also use the SQL language to set controls on data, to set security on data. All that stuff we saw in the console, we don't actually have to use the console at all. We can do it all through SQL language itself. But here's an example which if you are a system analyst, you should learn a little bit about the SQL language just so you understand what it is that the developer is thinking of when they try to access data from a database. Here's a very classic example of trying to get data, the select statement. This particular one is select star, or everything, from a table called employee. In other words, show me everything in the employee table. In this next example here, I'm selecting the first name and the last name, F name and L name. Now these are names of columns, fields, and salary from the employee table, but only under certain criteria, where the employee ID, emp ID, equals 1, 2, 3, 4, 5. In other words, give me the first name, last name, and salary of employee number 1, 2, 3, 4, 5. And so this is the way the SQL language is structured. And like I said, once you learn one of the languages, it's not hard to catch on to the other flavors of SQL. All database developers, all developers who write applications to talk to databases, they'll use this. One of the things that, as an IS auditor, I'm interested in is not so much the SQL language, but were people learning to use it properly? Like, I'll give you an example. We had some developers who didn't understand SQL or databases at all. They didn't understand that a SQL server itself is very capable of and designed to get huge amounts of data and produce that data very quickly and very easily. Instead, since they didn't understand that they could use SQL language to let the database server go and get the information, they wrote manipulating the data in code. And in some cases, we had one procedure being called 1,000,000 times to do something that a database server could have done very easily. And so here's an example of the developers not understanding the resource that they were actually using to access the data, which in turn caused the product to perform so badly that it had to be completely re-engineered. And so as the IS auditor, I'm interested in understanding, did these people really know the resource they were working with? And in fact, we wasted millions of dollars and years of work, because very quickly we got to a point where we had so many records that code, written in one of the C languages, probably C#, could not anywhere near quickly access the data as fast as a database system could. So as an IS auditor, when we are evaluating data administration practices, we're looking at, is the database exhibiting good design? Now, you may not be a database designer, but you can know because it's performing well. And on your team should be someone who understands databases. Can we access it easily? Are we administering it properly? Is the data portable? Are there good controls in place? Does a database model exist? Did somebody actually draw this thing out? Most database products will produce a graph, a diagram for you if you ask it to. Did we define what the data is? And are these definitions standardized and enforced? In large organizations where you have lots of people designing small databases, usually if they're going to create tables and naming and stuff like that, they very often will have a centrally controlled group of people who examine all this and make sure it follows naming conventions and data structure conventions in the organization. Or, like in our case in the health industry, we had to have very clear data definition, and we had to have very clear data dictionaries that conformed with other standards, other health data standards. Make sure that there's backup and recovery procedures in place, documented, and they're doing it. Make sure that access control is in place. We don't want just anyone reading sensitive or private or confidential information. Make sure that we don't have unauthorized users at all from updating data. We don't want people changing people's information. And we want to make sure that there is some kind of control where we don't have two people trying to update the same record at the same time. You can have situations where two records are dependent on each other, and then we end up in this deadlock situation, this deadly embrace where you're stuck and neither can move, and then the administrator has to go and actually kill the process. Make sure that all the accuracy, the controls are in place for accuracy. In other words, don't allow anything besides 2 letters for a state code, and it has to be within a list. Don't allow anything besides numbers in a zip code, and it has to be 5 numbers and then a 4-number extension. or it has to come from a specific list, or a country has to be a specific list. And also make sure that there are always checkpoints at various times in the database lifecycle and in the project management part that uses databases. Make sure there are always checkpoints to double check that we are always on point and on standard and doing our best to support the business functionality.